All right, so maybe you noticed something in the previous video, and it's that it took me quite a while to draw these simple structures. So what we're going to go over next is kind of seeing like an organic chemist. And we're going to start off with something that's called skeletal structures. So let's take a first look at some kind of structure that you knew, Lewis structures. And then we'll move into condensed structures. And then finally, where we want to end up and what we'll use for most of the time, skeletal structures. So let's draw the Lewis structure of ethanol, otherwise known as the alcohol that you drink, right? So it's a CH3, and then a CH2, and then an OH, right? So there's that guy right there. And so this ethanol is a very, very simple structure, right? Just two carbons, oxygen, and some hydrogens. So it's very simple. But it still took me a little bit to draw this. And then the other thing that you notice is that this picture is very cluttered. For something that's so simple, there's a lot of stuff there, right? A lot of bonds, a lot of elements. And so when you first look at it, you have to take a second to figure out, all right, this is a carbon, this is a hydrogen, there's an oxygen over here. It's very cluttered. And so another way we can represent this is through a condensed structure. So we could draw CH3, CH2, OH. And so you can see this condensed structure, assuming you kind of know about chemistry, gives you the same amount of information as this Lewis structure, right? It tells you that there's a CH3, and although it kind of looks like the bond is coming from an H, you as a chemist know that hydrogen only forms one bond, and so that can't happen, right? So there's some assumption that you have some knowledge. And so we're getting better here, but it's still kind of a lot to write. You're writing these C's, these H's, just a whole bunch of stuff, right? So we finally move on to the skeletal structure, and this one's going to be the best one. So here's ethanol in the skeletal structure. And then boom, I'm done. Look at that. Half a second to draw ethanol. And so this is the best one. And this still contains all of the same information that the Lewis structure does, assuming you know how to read it. So let's take a look how we went from what's on the left to what's on the right. So again, I'm just going to rewrite what we had up there, skipping the condensed one. It's rarely used. I mean, you can just see how long it's taking me to draw this simple Lewis structure. And then when I go to the skeletal one, how quick that is, right? You can see the difference in speed. And so take a look at these different compounds. First thing you'll notice is this CH3 over here. That's represented by the end of this line here. So this little line here, that's a CH3. And so what you can take a look here is that there's only one bond shown, right? The only bond you see is this bond. But you as a chemist know that carbon forms 4 bonds. And so hydrogens, we don't draw hydrogens. And so we just assume that there's 3 more because we know carbon always forms 4 bonds. So if it only has one shown, that must mean that there's 3 other hydrogens. And then this CH2 right here, it's represented by this point right here. And so you see that this carbon has 2 bonds, right? One to the other carbon, one to the other oxygen. And so that means that there's 2 hydrogens attached to it. So there's 2 bonds shown. Carbon has to have 4 bonds. That means that there's 2 additional hydrogens. And then finally, this OH component, we write as this OH. So anything that's not carbon has to kind of be explicitly written. But you'll notice that we omit the lone pairs. We simply assume, since you're a chemist, you know that if there's an oxygen with two bonds and it's neutral, we assume that you know that there's two lone pairs there. We do show the H here. Anytime the hydrogen is not bonded to a carbon, it is shown. So just some kind of tips here. Neutral carbon has 4 bonds. And so these carbons are represented as endpoints of a line. Any hydrogens attached to carbons are not drawn. As we can see here, right? We didn't draw these carbons or these hydrogens. We simply assume that there are as many hydrogens as needed for carbon to have 4 bonds. And then any lone pairs are optional. Sometimes you'll see them drawn, sometimes you won't. It's totally optional. But even when they're not drawn, they're still there. We just assume that you realize and know that they are still there. But again, at the end of the day, it's all about drawing these things efficiently and clearly. And the Lewis structures, when we get to more and more complex structures, they're simply too cluttered.